You know that feeling. You get to the airport, and there's just this thick, soupy visibility everywhere. Flights grounded, we see it all the time as pilots. But do you ever really stop and think, what kind of fog is this? And what does that tell me about how it's going to behave? This is where it gets critical, especially if you're working towards your ESA basic instrument rating, the BIR. Because you're dealing with really strict visibility and ceiling minima, the absolute lowest you're allowed to fly in.
Right, and what's fascinating and frankly essential is that not all fog is the same. Not even close. If you understand how it formed, you get, well, a massive clue about how it's likely to act, how predictable it is, and that's absolutely vital for your go-no-go decision as a BIR pilot. It's about truly understanding the conditions, not just, seeing white outside.
Okay, so let's dive into that. What are the main types of fog we pilots really need to be able to distinguish when we're facing low Vs?
Good question. There are several key players. First up, you've got radiation fog. This is your classic overnight fog. It usually forms on clear, calm nights. The ground cools down fast, radiating heat away, and chills the air right above it to its dew point. Think of it like dew, but, suspended in the air. Usually burns off pretty quickly once the sun gets to work.
Ah, okay, so in the cockpit, that might mean what delaying for an hour or two could actually work.
Exactly. If you can wait it out a bit after sunrise, chances are good it'll clear up enough for your BIR minima. So it's about a strategic delay, not necessarily a cancellation.
Got it. So that's the ground cooling the air. But what about when air itself is moving around, bringing different conditions? That must change things.
Oh, absolutely. That brings us to advection fog. This happens when warm, moist air moves horizontally, like across the ground over a cooler surface. Think warm sea air moving over cold land or over a cold ocean current. The air gets chilled from below until, bang, it hits its dew point.
And this one sounds more persistent.
Much more persistent, generally, and it can cover a huge area. Unlike radiation fog, waiting an hour or two often won't cut it. This is the kind that can sock you in for hours, sometimes even days.
Okay, so radiation fog, maybe, wait, advection fog, probably a no-go for a while. What else? I've seen that sort of steam coming off lakes early on cold mornings.
Yep, that's another type. Steam fog. Some call it sea smoke. That forms when really cold, dry air moves over much warmer water. The warm water evaporates quickly into the frigid air, but it immediately condenses because the air is too cold to hold it. You see it over lakes, rivers, even wet tarmac sometimes in the winter. It can be quite localized, but dense where it occurs.
Right. And what about weather systems? Like fronts, does fog come with those too?
It certainly can. That's frontal fog. It's typically associated with warm fronts mainly. Rain falling from the warmer air above evaporates into the cooler air near the surface. This bumps up the moisture content until the cool air is saturated, forming fog. This type can be widespread and tricky because it's tied to the movement of the whole frontal system.
Okay, one more.
One more common one, orographic fog or upslope fog. This is simple physics, really. Moist air gets pushed up the side of a hill or mountain. As it rises, it expands and cools. If it cools to its dew point, you get fog clinging to the terrain. For pilots, this means mountain passes can just disappear.
Wow, okay. So we've got the different ways fog forms. Now, the critical part for us BIR pilots facing those tight minimums, how does knowing which type it is actually change the no-go decision? Where does the theory meet the pre-flight check?
This is where it really pays off. Let's go back to radiation fog. You identify it, maybe check the forecast confirming conditions for it. You might decide, okay, I'll plan for departure at 10 a.m. instead of 8 a.m. You're making an informed bet that it will clear to meet your minima rather than just scrubbing the flight immediately.
Right, you're using the knowledge predictively.
Precisely. But if you look out and see conditions screaming advection fog, maybe there's a steady breeze bringing moist air off the sea over the cold land, you know it's likely to stick around. Waiting probably won't help you meet those BIR visibility or ceiling requirements. A no-go becomes a much more likely and prudent decision. You might need a whole new plan.
And frontal fog also
Yeah.
sounds like a be cautious signal.
Definitely. It's tied to the front's movement, so its dissipation is less predictable and often covers a large area. Very conservative approach needed there. Steam fog might just affect your specific takeoff path or landing zone if it's over water or a damp runway. Orographic means staying clear of terrain, maybe a reroute. The bottom line is, evaluating what kind of fog it is, not just that there is fog, gives you a massive advantage in predicting the conditions and making a safe call based on those BIR limits.
So wrapping this up, it's clear that understanding the different flavors of fog is more than just academic. Knowing how radiation, advection, steam, frontal, or orographic fog forms gives you real insight into its likely behavior. And that directly impacts your safety and decision-making, especially under ESA BR rules, with those minimum visibility and ceiling requirements. It's not just white stuff, it's got a personality.
Exactly. It adds a layer of sophistication to your risk assessment. You move from just reacting to the weather you see to actually anticipating what it might do next.
So here's something to think about next time you're doing your pre-flight checks, looking at the METAR, peering out the window. Are you just seeing fog? Or are you taking that extra step to figure out what kind of fog it is? Could understanding that difference be the key that prevents a risky go decision or confidently supports a safe no-go? Definitely something to mull over.